Hi everyone, I'm going to demonstrate the sign change or decimal search method using GeoGebra. The first thing we should do is I've got the graphics open and I've simply gone to view spreadsheet to get the spreadsheet on my right over here. The first thing we should do is enter our function. So at the bottom we'll put fx equals, let's play around for function, we've got x cubed. I can go to the right at the bottom and pick cube, take away 3x and then plus 1, and we get, there's our cubic. Before we continue, it might be a good idea to annotate and label this. So one of the things to do is cancel, let's go back, we don't need that point there. Right, so if I do right click, do object properties, I'll have name and value, and we can also change the color. Let's change it to red. Okay, and there we go, there's our function. Then at the bottom you can see I have the equation of the function, or the expression of the function rather. Now if we can see, obviously there's a root between -2 and -1 and 1 and 2. And one of the things we want to do is just to illustrate the fact that we're going to look for a root. Let's say it's a root between 1 and 2. And so what I'm going to do is use the function inspector just as an illustration tool. And so I click on the function and it gives me some details. Now what I'm going to do is at the bottom over here, I'm going to choose 1, and I'm going to choose on the other side 2. Now I could have as well just moved these points around to select the regions as well. Now it clearly shows me that obviously on either side of this root, when x equals 2, fx is positive. When x equals 1, fx is negative. So I might want to add that in, that fact. So let's use the text and say f2 is in fact greater than 0. Okay, and so we've got that there, and that's what that shows. And over here we can also add some more text and just say that f of 1 is in fact less than 0 in this region. Okay, let's just move that text over here. And we can also say, maybe put a note over here just to say that we're looking for a root. So we want to find the root in the interval 1, 2. Okay. And so therefore that's what we want. You can add in arrows or things like that as well. And there's our little illustration. Now, to actually find the root, we need to use decimal search method and look for change of sign. And we could label this as x, for example, and this column here as f of x. Okay. And let's start with, let's work with one decimal place. So you've got 1.1. Okay, so 1.0, and the next one's going to be 1.1, and it goes up. And we go all the way down. Okay, to 2. And what we're going to do here is on the next column for f of a2. So that means we've already defined the function, and GeoGebra knows that. And so therefore, if we take a2 as our input into the function, it in fact gives us -1. And then we can drag that down. Okay. And we get these values here. Okay, we can clearly see that over here, this is where we have a change of sign, so we can put that in bold, maybe highlight it. And one of the things I'm going to do is we're going to work down to 5 significant figures. And one of the things we need to do is in fact to change the rounding to a greater number of decimal places. So I'm going to actually choose 10 decimal places as we go down. So that would be quite helpful as we go down, we get more and more decimal places by FX. Now let's take, in fact, before we move on, we need to have two zoomed graphs. So let's have a look. Let's zoom in. Okay, so I'm going to hit the zoom button and in fact move in. And we need zoom graphs to 1 and 2 decimal places. Here's 1 decimal place. And we can change our values now to 1.5. Okay, and now we can have 1.6. Okay, so that's a region that we've just focused on. Maybe we can move in a bit more. Actually, let's zoom out. You can also use a mouse to scroll and it does the same thing for you. And so we're effectively looking for the root that lies between this interval. Again, we can annotate, label these points and say when f is 1.6, the graph is in fact positive. When it's 1.5, its fx is negative, and obviously the interval lies between that region. So that's my first zoomed graph. Now let's take 1.51 and that should be 1.50, 1.51. So now working to 2 decimal places, and we can copy that all the way down to 1.6, and let's put a function of A14 into there, and again we can copy this down all the way to all the way down to the bottom. And again we can see a sign change, and this sign change lies to 1.53, and we can highlight that. Later on we can copy these columns down into our Word document and arrange them in a table in a more something that's a bit more organized and neat in terms of the way we'll present our data. Now, it would probably be a good idea at this stage to zoom in and get a second zoom of our graph. So let's zoom in a bit more. And this time we want 2 decimal places. Here we've got 2 decimal places, and this time we want 1.53 and 1.54. So it's that region there. And just to emphasize, that's the region we're looking for. And we can zoom out a bit, and that's gone down to 3 decimal places. Okay. I think one of the advantages of GeoGebra is it's really easy to move things around. You can easily click, for example, here, and move the axis, increase or decrease axis. So it's really easy to create an image. You can also export this image or simply take a screenshot of this image. So if you want to take a screenshot, maybe you can take these values here along with this graph. And again, please do annotate and explain how these 2 points, one is positive, one is negative, and therefore the root lies between these 2 points. Let's now carry on. So we've got our 2 zoomed graphs. Let's do 1.530 and 1.531, and we will take that down all the way to 1.54, and let's just copy that down because that's just the same function, and we can delete these values there. Okay, and again we've now found that we're getting closer and closer, and here we have a sign change in FX. We can repeat this process. We go down, let's have a look. So we've got 1.5320, 1.5321. Okay, copy this down and copy this down all the way to 48, and again, we'll copy this down all the way down and get rid of these two values here. And again, we have a sign change. This time it occurs right at the beginning. And highlight that, put that in bold. And we reach the 4 decimal places. We want to work to 5, so we've got one more set of calculations to do. And we've got 1.5321, 1.5320, 1.53201. Okay, and now we work into 5 decimal places and copy that all the way down to 60. And let's take that down. Okay. And here we've got our results. Now we can see that the 5 decimal places, there's a sign change that occurs over here. And so therefore, for up to 5 decimal places, what we'll do is in fact take the midpoint between those two values. So we'll say x equals 1.53208.5. Okay, and within an error bound of plus or minus 0.5 zeros, 1, 2, 3, 4, 5, and a 5. Okay, maybe I'll pull that out. And so there we have it. We've worked out the route to 5 decimal places, and we've stated the error bound to those 5 decimal places with a maximum error. So therefore we can conclude that the root is 1.532085. Now if we add the error bound, we get 1.53209. If we subtract it from our value of x, we get 1.53208. And we know the root lies somewhere in between that.